So it's
something happened.
There we go. Okay. I'm not going to even bother introducing, but I've already spoken about it. So there's been enough today. So I just hand you over to Dr. Maurice Gleeson.
Thank you very much.
Very well.
Lovely to be here, and thanks very much for the invitation to speak. It's great to be back at the gCais and talking about a topic that I am fairly passionate about, and that is an aspect of DNA research. Now, if I stand here, can you see that okay? Yes. Lovely. Okay. So I'll be talking today about researching Irish clans using DNA and documentary records. And this is quite an interesting topic because it's only really in the last couple of years when the technology has improved to the extent now that we have a very, very interesting overview of the tree of mankind, and we're coming down the tree of mankind into the time of the clans and into the time of the surnames. So how many people in the audience have actually got a Surname DNA project that they run? There's one or two over there that have an actual project. And how many people have done a Y-DNA test? Again, a few people there. It's started off as being a very useful tool for researching your surname, but there's been a lot of activity over the last 5 to 10 years on the clan side, and I think we're going to see much more of that now, especially with the likes of Dan Bradley in Trinity College Dublin, genotyping the ancient remains of about 150 Irish people going back to about 6000 BC or thereabouts. So this is all a very exciting time because there's going to be a huge amount of overlap between the work that they're doing in ancient DNA, the work that we're doing in genetic genealogy and using Y-DNA to trace surnames and then back into the clan era, and also archaeology and ancient genealogy research. So we'll be talking about this topic over the course of the next 40 minutes or so. This is a crude timeline. You see here that the time of surnames is from about 1000 to the present day. So in Ireland, surnames arose roughly 1000, maybe 1100 years ago in the 10th century. And it's probably the earliest time in Europe that surnames arose. Before that, going back to about the time of Christ, it would be the era of the clans. And we have ancient genealogies and ancient annals that document specific events that occurred over the course of time that can take us back to about 2000 years ago. Now, speaking with Bart Yaski at Genetic Genealogy Ireland in October of last year, he's studied the annals, and he would say that back to about 600, they're probably fairly accurate. But before 600 AD, they start to get a little bit iffy, a little bit dodgy. So we do have some reliable genealogical data that goes all the way back to about 600 AD. And before that, there is a question mark about the veracity of a lot of the documentation. And these are just some maps from Ireland's History and Maps, which is a very nice website that was put together by Dennis Walsh, starting around about 2003 or so. And it's got a very, very nice summary of some of the major clans and their geographic locations in Ireland. Now, the kind of resources that we use for doing this kind of Irish clan research would include things like surname dictionaries, the ancient annals and the ancient genealogies, which we'll talk about, previous analysis by antiquarian scholars, because of course these genealogies have been around for centuries. And we are not the first people to be looking at this literature. So there's a lot of antiquarian scholarly work that actually is quite interesting, and a lot of it is available online, either through Google Books or archive.org. So it's well worthwhile looking to see what has gone before and what people have said. Now, surname distribution maps can also be very, very useful if you like to kind of verify what the annals seem to be telling us about a particular geographic location for a clan. And then there's the various DNA projects of Family Tree DNA. And you've got four main types. You've got your standard surname projects, so anybody with a surname can start a project and research that particular surname. You've got geographic projects, such as the Ireland Y-DNA project or the Munster Irish project down in the south. You've got clan DNA projects, such as the Sons of A, which is associated with the Dáil Queen group project. And that looks at is researching all the descendants of Conn of the 100 battles. So that's a specific clan project, and that's going to be located mainly in the northwestern corner of Ireland. And then you've got haplogroup projects, and these would be projects that deal with specific branches of the tree of mankind as defined by DNA. So there's a lot of overlap and synergism between these various projects, and some important tools that we will be using for analysing the DNA include the haplotrees. And these are the trees put together based on genetic mutations that we see in the DNA. We'll be looking at a few of these over the course of the next 40 minutes or so. And then there's other resources, like I said, like ancient DNA. And that is a very, very exciting area. Did anybody catch Lara Cassidy's talks in October at the RDS? Few people. Absolutely fascinating work that she's doing. Her thesis was supposed to have been published in May. I'm not sure, it's been embargoed now for another couple of months. But when that does come out, it's going to be very exciting. And of course, that ancient DNA can help us, because it's carbon dated, it can help us date much more specifically the time that a particular mutation on the DNA arose. Just to remind you, we're talking about Y-DNA exclusively here, and this is passed from father to son along the direct male line, and it has a very extensive reach. This can go back over 200,000 years ago to genetic Adam in Africa. And if you do this test, you get a very nice printout from FTDNA of a map of the world showing where your ancestors came out of Africa 250,000 years ago. Real coffee table stuff. But it's very, very useful for researching deep ancestry and human migrations, for following surnames back in Ireland to roughly about 900 AD or so, for connecting yourself with same surname cousins. So these would be cousins with whom you're connected by a common ancestor on your respective direct male lines. Father, 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 common great, 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 great grandfather, that type of thing. There's a lot of surname projects. There's more than 10,000 of them on family tree DNA. And the clan studies have recently started. The Sons of A is the only one that I know of, but the Munster Irish Geographic Project has also done a very, very useful analysis in their study. And there's also the Three Collas Project as well. So there are actually a few clan studies on family tree DNA. They have over 700,000 Y-DNA tests in their database, so it is the biggest database for Y-DNA. And that's completely different from the test you'll get at Ancestry or MyHeritage or 23andMe. And really you have to go to Family Tree DNA if you want to do surname research, and especially if you want to do clan research. Most important thing to kind of take home at this point in time is that there are two types of DNA marker. There's the STR marker and there's the SNP marker. So you just have to remember there's two types, and we'll be talking about them later on. This is a nice map showing the human migration from Africa 250,000 years ago, and you can see that they kind of spread out all across the globe down to Australia. The tip of South America was the last point, well, New Zealand was the last point on Earth to be populated by humans, roughly about 1400. So they've only been there for about 600 years. And as a result of that, in New Zealand, when you test the Maori population, they all match each other, because there's a lot of sharing of that DNA that's been going on, a lot of pedigree collapse and endogamy in that particular population. And of course, as humans moved across the Earth, they developed some mutations, and the ones that developed mutations over here were different mutations to the ones that developed over here. So after a while, you begin to see that specific geographic areas become associated with a specific DNA signature. And that can be very, very useful when we come to clan research. The other thing that you can do is you can build a family tree for all mankind based on the DNA mutations. And when we started this off, there were only 20 major branches, labeled A to S. These are called haplogroups. Each branch is is called a haplogroup. In 2002, there were only 16. If we look at the OR branch down here, which is the most common one in Western Europe and most common one in Ireland, about 81% of people in Ireland have this particular haplogroup. It was only 16 sub-branches in 2002 that grew to 24 3 years later, and then 5 years later was up to 71, and 3 years later was up to 290, and then there was more than 5,000 in 2017, and there's more than 10,000 in 2019. So there's been some real exponential growth, and of course as we define more and more branches on the tree of mankind, we're moving from upstream, close to Adam, down towards the present day, so that some of you who have done the Big Y test, you'll find that you have private SNPs, they're called, unique SNP mutations that you only have. You're the only one in the database to have this mutation. So it's a very exciting time for SNP markers and for Big Y and for Y DNA testing in general. These are the type of haplogroups we get in Ireland. Haplogroup I1 and I2 are around about 6% each. OR1B and OR1A, 81% and 2.5%. Wouldn't you like to have seen these kind of percentages in the election? Never mind. Then these are the geographic areas associated with each of these particular haplogroups. So you can see I1 over here is only about 6% of the Irish population. I2, you can see it's very little bit in Ireland. It's mainly around the Caucasus, whereas I1 is mainly up in Scandinavia. OR1A is a Northern European one. There's some in Ireland, but by and large, OR1B is the highest with 81%, and Ireland has the highest concentration of any country in Europe. If you compare it with the Vikings from Norway, you'll see that they have 31% I1 compared to our 6%, and with OR1B they only have 32% compared to our 81%. But you can see how DNA is associated with specific geographic locations, but not only that, we're now getting down to sub-regional levels. So this would be where the DNA marker Z253 is mostly prevalent in Munster. And not only is it associated with a geographic location, it's actually associated with surnames. We find that people with this particular marker there tends to be a surplus of specific surnames with this particular marker. And that potentially could lead us back to the ancient genealogies and the fact that some of our ancestors, their descendants gave rise to a number of different surnames. And one of the greatest studies that has been done recently is the work of Dennis Wright working with the Dal Gosh, and we'll be looking specifically at his work. Now, the reason why Y-DNA is so useful is because it follows the direct male line, father, 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 as does the surname, but not all the time. If it's a patronymic surname, like they have in Thailand, like they have in Iceland, it changes every generation. Just like the on the direct female line, your mother's 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 line, the surname changes every generation. So in Iceland it changes every generation. Peter Richardson was the son of Richard Thompson, who was the son of Thomas Peterson, who was the son of Peter Eriksson, and so on. It changes every generation. In Ireland and in most Western countries we have inherited surnames. In some places they started quite late. So for example in part of Wales they didn't start until the 1850s. Before that it was patronymic. And usually it's passed down in an unbroken line, but sometimes you can get these switches. And we'll be talking about these surname or DNA switches. Sometimes it can be due to infidelity. So for example, if you started off being an O'Brien, maybe the wife was having an affair with the neighbour next door, Mr. Red, and the Red DNA was passed down into one of the children, unbeknownst to the husband. It wasn't his, it was the next door neighbour. And that Red DNA continued for quite a few years until Mr. and Mrs. O'Brien, because the name was still O'Brien at this stage, they decided to adopt a child. But they never told the child he was adopted. and so that child believed that they were the natural parents, and he continued the O'Brien surname down to the present day. So he comes to Family Tree DNA to have his DNA tested, and they say, well, you might be an O'Brien by surname, but you're a Green by DNA. And he does a little bit of research and tests his cousins, you know, second cousins, third cousins, fourth cousins, who are on that direct male line, and he discovers that it changes to a Mr. Red back in the 1880s. And in actual fact, there was a Mr. Red who was a lodger in the house, according to the census. So that's the smoking gun. And if he's lucky enough, he can go all the way back and he finds out that maybe eventually he was an O'Brien, but it may be very, very difficult to find the point at which the break occurred. Now, Y-DNA has evolved quite remarkably over the last 10 years or so, 10 to 15 years. We started off with 12 markers actually in the year 2000. It went up to 37 in 2003, 67 in 2006, 111 in 2011, then 561 in 2017, and now you can get over 700 of these STR markers. Then SNP testing was introduced, and SNP markers are the second type of marker. We had SNP packs in 2005, a very experimental Walk the Y program started in 2007 and identified a lot of new SNP markers on the Tree of Mankind. That was replaced in 2013 by the Big Y 500, which in turn was replaced last year by the Big Y 700. And now we're looking at over 200,000 SNP markers on the Y DNA, on the Y chromosome. And again, that just stresses that there are two different types of DNA marker. They are complementary to each other, and it is best to test for both of them. The type of DNA signature you get with the SNP marker, you can call it a SNP signature or a SNP progression, and it really is just a series of names. And each of these SNP markers just characterizes a particular branch on the Tree of Mankind. And these characterize the branching points all the way down to this one here, DC 307. It may have arisen 1,000 years ago, it may have arisen 200 years ago. In comparison, the DNA signature with STR markers is a series of numbers. So here you have the names of the STR markers here, and here you have the results for 3 people stacked on top of each other. And each marker has a value, and that value is just a number. So what you do is you compare the string of values with one person against the string of values with another person against the string of values with a third, and you can see they're exactly the same, apart from this little mutation down here in pink, which is highlighted. And this would mean that these 3 men are relatively closely related. They probably all share the same surname, and you're probably looking at a common ancestor somewhere in the last 200 to 400 years. Somewhere in that range. So it can help you with your own individual genealogy, but this Y-DNA test is not going to be as informative for day-to-day genealogy as, say, the tested ancestry or MyHeritage or 23andMe, because that's more geared towards a different type of DNA, which is probably much more useful and gives you more bang for your buck in terms of helping you with your personal genealogy. Y-DNA is largely for researching a specific surname, and as we're talking about, researching a specific clan. And these are the type of DNA tests available. There's now only 2 types of STR test, a Y37 and a Y111. This is 37 markers, this is 111. That'll cost you $119, this will cost you $249. And the SNP, the big Y700 SNP test, will cost you $449. So it's an expensive test, and it's not for the faint-hearted. And I always say to people, don't start here, start here. Start with the cheap one, because you might test and you might find, oh, I match my second cousin. I never knew that he'd done the test. But not only that, he's done the big Y700, so I don't need to do it now because he's acting as a proxy for me, and save yourself a bit of cash. Now, this is Dennis Wright's study, and this really was a seminal paper that established the initial criteria for defining supportive evidence linking a specific DNA signature with a specific Irish clan. That's the paper there. He also gave a very good presentation of it at Genetic Genealogy Ireland back in 2016, and that's available on YouTube. You can view that for free. And basically, the criteria were, among men with a specific DNA signature, a substantial proportion of them have direct male line ancestors who came from or near the ancestral clan territory. So we're looking for a specific geographic location with this first criterion. The second criterion is that with people with a DNA signature, there's a significant excess of surnames associated with the clan. They would have been surnames that descended from the progenitor of the clan. That's criterion 2. You can also look at it the other way around. Hi, Gerard. Among men with clan-associated surnames, there's a significant preponderance of the specific DNA signature. And we're going to take a look at how Dennis demonstrated that. And lastly, people with an extensive pedigree, say greater than 20 generations, and there are people around that have that, they also share that same specific DNA signature, and we'll show you a very, very good example of that. So, it started off back in 2006, which is 14 years ago now, and this was before SNP marker testing was readily available, and a distinctive Y-DNA signature based on those STR markers, those strings of numbers, was noted by Ken Nordfeld. And this is the actual signature here. These are the markers, these are the values that that particular signature had. There was already an established Irish DNA signature called the the Atlantic modal haplotype. And again, it was distinctly different from this new signature that had been discovered. And they called it the Irish type 3. And they found that a lot of people who had this particular string of numbers, a lot of them came from Southwest Ireland, Clare, Limerick, Tipperary. So Dennis writes, nobody was researching this, so Dennis, who lives in Australia, he set up this Irish type 3 website, IT3 website, to explore and investigate this particular STR signature. And there's the website there, it's got lots of information on it. And then subsequently he launched the L226 project, because when SNP markers did become available for testing, they found that the IT3 signature was also characterized by a specific SNP marker known as L226. And he then went on 3 years later in 2009 to publish this seminal paper. And the reason why, of course, the Dalgash are so popular in the mind of the average Irish person is because one of their most famous sons was Brian Boru, defeated the Norse-Irish army at the Battle of Clontarf. He really established the power of the Dalgash dynasty. And it was a major turning point in Irish history and changed the political landscape forever. And here's a lovely photo of the battle. And on one side you had Brian Boru, and there you can see him in his tent, exhorting the lads. He was in his late 70s or early 80s at this point in time. And there were Viking warriors from Limerick fighting on his side. And then on the Dublin side you had a Norse-Irish alliance of Sitric Silkenbeard, the Norse king of Dublin, Mael Morda Mac Morchada, king of Leinster, and then an external Viking force commanded by Sigurd of Orkney and Brodir of Man. And this yellow point on the map is very important because that's where my granny used to live, and she would have had a bird's eye view of the battle if it had gone on a little bit longer. So that was the Battle of Clontarf. It was reenacted in 2014. Very disappointing result, unfortunately. Vikings 2, Brian Boru 1, but that's just the way it goes. And what Dennis did was to explore whether or not this IT3 signature belonged to the Dalgash. He went to O'Hart's Irish Pedigrees, the origin and stem of the Irish nation, freely available online, easy to consult, and you can see there that they the following is the stem of this family from Cormac Cass, who was the ancestor of O'Brien of Thomond, and a younger brother of Owen Moore. He also, yes, so he mentions Cormac Cass there, and on, I think it's the next page, yes. But using this, and it goes on for several pages, and I'll show you some of the main points, he built a family tree for the Dál Cosh. Particularly interested in identifying surnames that became associated with the clan. And then he dated each branch in this family tree for the Dál Cosh, because he will want to compare that later on to the branching point dates defined by the DNA. And this is one of the main pages. You can see that all of the dates in black are actually within the text. So 926, let's see, well actually we've got 347 is when Coss was born, 926 is when Brian Boru was born. And in red we have, red italics, we have, I estimate the intervening generations by just applying 30 years per generation. But you'll see that here there's 540 and he had his son in 641. So my estimate of 540 is probably wrong, because it would be unlikely that somebody fathered a child at the age of 100. Although having said that, back in ancient Ireland, you know, some kings had 10 wives, and they'd have their first wife, marry their first wife when they were 20, and the 10th wife when they were 70. So there could be huge intergenerational gaps. But I suspect that just my calculations are out, and it points also down here, there's a 121-year gap between these two people, so there's something wrong there. Either the dates are wrong, or alternatively, and this is one of the issues, the tree is condensed. You know, not all the generations have been included in this summary, and some of the direct male line descendants are missing. And this is a feature of some of the genealogies that you'll find online, is that some of the less important descendants have been left out. So that's one of the major issues with these online, well, with these clan histories in general. And if we look at some of the green boxes, it says the eldest son of Cos, Aquo, Bloodir, anglicised Blair, Flannery and Blood. So this is where we start identifying these clan-associated surnames. And here we have Blair, Flannery and Blood. Here we have the progenitor of O'Curry, O'Cormacan and O'Sosnan. Here we have Aquo O'Keefe, anglicised Coombe, the ancestor of Noonan, O'Mara, Scanlon and MacArthur, Cosgrave, Hogan, Lonergan, O'Brien, Aquo, many families. That's interesting, because they're not naming who those families are. Among other families, and at the very bottom it says etc. So some of the surnames are left out as well, and that's an issue. It is not an exhaustive list, and there are branches missing, and that may create problems when we're comparing the DNA with the actual clan-associated surnames family tree, because we may have a very strong DNA match to a particular surname that doesn't appear in the tree that we've generated from the clan history. And that might very well be because it's one of the surnames that was left out. Now there are also errors in a lot of these genealogies. Conflation is probably a frequent error, where perhaps a father and a son were called by the same name, or an uncle and a nephew were called by the same name, and they're accidentally conflated into the same person. So there's some evidence of that in some of the genealogies. And of course, in the later genealogies especially, if somebody wanted to have political power, they would massage the genealogy and insert their own ancestral line in there, and we've seen that in a number of places. And Catherine Sims, for example, says one way to try and figure out whether this is true or fake news is to look at some of the older sources. Because they may, the older sources which predate the person who wants that political influence, they may not have that particular line, and that's kind of a smoking gun that the line was inserted for political reasons at a particular point in time. The other problem with a lot of these clan genealogies is that they stop at 1600, and then there's a 400, well, maybe a 200-year gap between the clan histories and where your own personal genealogy picks up. So trying to bridge that gap is a challenge. There's no link to today, but DNA can possibly help bridge that gap. And that's another very exciting aspect of doing Y-DNA testing. So this is the family tree of clan-associated surnames that Dennis created from that genealogy of the Dalgosh in O'Hart's Pedigrees of the Irish nation. And he also has on the left-hand side a crude timeline. And there's Brian Boru, born around about 926, died 1014. And there's Cos. And all along the way you see that there's a variety of different surnames, and we have roughly an idea of where they branched off from the main stem of the Dalgosh. For example, the ones who descended from Brian Boru would be O'Brien, McConsidine, McMahon. They all came as direct descendants of Brian Boru. And then moving across, the more distantly related would be things like Cosgrave and O'Hogan. And even more distantly related, we have O'Mara, Scanlon, MacArthur, and all of these ones out here. Now, so essentially we have a family tree with many branches anchored by specific dates that we were able to get from the annals and the genealogies. The question is, are they all genetically related? Because if there has been an unbroken line from father to son, we should see this reflected in the DNA. Surname distribution maps can be useful for kind of just doing a sense check on the annals. So for example, here are quite a few of the surnames that are mentioned. You can see that Considine is very heavily concentrated in Clare, and of course the Dalgosh were centred around Thomond, which would have been around the Limerick area. So you're looking mainly at Clare and Limerick and a bit of North Tipperary as well. We also see quite a concentration of Eustace in that area, and McMahon as well, although it tends to be a little bit more ubiquitous. And then some names like McGrath, like Hogan, and like Casey don't necessarily cluster around the Thomond area. There is a concentration there, but Casey, for example, there were 6 different septs of the Casey surname, and that's always going to be a big question. You know, you might be a Casey, but which one of the 6 groups did you actually belong to? And that's where DNA can help as well. So the first criteria that Dennis explored was, among men with the specific DNA signature, in this case was IT3, a substantial proportion of them have direct male line ancestors who came from or near the ancestral clan territory. Well, he found 191 people with this particular IT3 signature in the databases at the time, which were YSearch and Sorensen Molecular Genetic Foundation database, both of them defunct now. He found that 54% of these 191 people had recorded their country of origin, the vast majority, 75%, coming from Scotland, and of those who had recorded a county of origin, 11 from Clare, 10 from Tip, 7 from Limerick, and 6 from Cork, out of a smallish total of 43, but you can see how it corresponded quite nicely with the ancestral clan territory of the Dalgosh. The most recent figures are still consistent with what those earlier figures were shown, and again the highest number of people are in Clare, and then Tipperary and Limerick with 45 and Cork with 34 out of a total of 238. And there probably is some nice statistical way of showing a correlation coefficient. I'm not a statistician. I wish I was, because it would be nice to have a statistician come up with some nice juicy statistical algorithms that could help us say that beyond reasonable doubt there is a very strong correlation with this particular geographic area. And there's the most up-to-date map of the geographic area, and you can see that 11 years later it's still concentrated around the Clare, Limerick and Tipperary area. The second criteria, among men with a specific DNA signature, there is a significant excess of clan-associated surnames. And what he did was he looked at the percentage of men with the signature and whether they had Dalcassian surnames, like you saw on the family tree, or non-Dalcassian surnames that had nothing to do, were not traditionally associated with the Dalcas. And 29% of the sample had Dalcassian surnames, but 71% did not. Now, why is that? Why did so many people with non-Dalcassian surnames have the IT3 DNA signature, and is this unexpected? Now, remember that Cos was born in about 347 AD, so we're looking at 1,650 years of Y-DNA transmission from father to son, from father to son, from father to son. And along the way, we might find that there has been an NPE or an SDS. NPE stands for a non-paternity event, otherwise known as not the parent expected. And it also can be known as the surname or DNA switch, which I prefer because it's a lot less judgmental. And there are many different causes for surname and DNA switches. And one of the most ancient ones is allegiance to the lord of the Tua. And this would have been done by servants, by vassals, by tenants, and by slaves. And to quote an example from the life of Grace O'Malley, from Anne Chambers' biography of the Pirate Queen, who lived from 1530 to 1603, she became a matriarch not merely of her own followers and extended family, but of neighbouring clansmen whose chieftains had either died in the numerous conflicts of the period, or who had abandoned their obligations to protect their dependent followers. So what would these people around Grace have done? They would have said, I'm going to pledge allegiance, I'm going to become an O'Malley, but they're bringing Mr. Red DNA or Mr. Green DNA. So now you're getting a variety of different Y-DNA signatures associated with the O'Malley name. And this would have been true for any of the powerful clans. So whereas previously we looked at infidelity and adoption as potential causes of these surname or DNA switches, we're now looking at allegiance to the chief of the clan, or social status is another one as well. And there's some great examples of that later on. Under Brehon law, there was a lot of adoption, fostering, and guardianship. For example, if a young widow remarries, she will have her young family take on the second husband's name, and maybe all the children change their name to the second husband, but they'll still carry the first husband's Y-DNA. It could be a legal condition of marriage or inheritance. You will not marry my daughter unless you change your name. Taking the wife's name upon marriage. Oliver Cromwell was actually Oliver Williams, but he married the great-granddaughter of Thomas Cromwell. She had much higher social status, so he changed his name to Oliver Cromwell. Customary coupling with powerful people. This definitely happened in Wales. I'm not sure if it happened in Ireland. I suspect it probably did, where if a powerful lord was staying, to ensure that he felt safe, the local chief would offer one of his wives to him to keep him company during the night. That way he could be assured that nobody would run in with swords and start stabbing him in the bed. And associated with that is this idea that on the deathbed, the wife would call the husband in and say, oh, by the way, our third son, he's not yours, he's the O'Brien's. So there's that very unusual custom under Brehon law, and of course the whole concept of infidelity and illegitimacy was very, very different under Brehon law than it would be today. And another very important reason for why you get these surname or DNA switches is Anglicization. And a lot of the Irish names would have been Anglicized to the nearest equivalent English one, a lot of the time incorrectly. So for example, you might find that the Greens, the Hoonies and the Fahys are all genetically related to each other because they all have the same ancestor. And Hoonie and Fahy would have been Anglicized to Green over the course of time. And there's many other causes as well. But roughly, every single one of us, if we went back along our direct male line, there's a 50-50 chance that we will not we will have an unbroken line going back to the progenitor of our particular surname. So, you know, it's highly likely that a lot of these switches will occur over time. And for that reason, this 71% of people with non-Dalcassian names is not as surprising as it first seemed. Because the O'Briens and Dalcash being powerful dynastic lords and chiefs, a lot of people would have sworn allegiance to them and would have changed their names accordingly. And Bartiaski has coined this term surname gravity, where people with important surnames who are very, very powerful, people would swear allegiance to them, so there's a more tendency of the common folk to adopt these powerful surnames rather than adopting a non-powerful surname. It would be interesting to see whether we get the same pattern with other subgroups, genetic subgroups that are known to exist in the Munster area. Z253, Z255, they have nothing to do with the Dalgash. And it would just be very interesting to do a comparison, and that's something that I hope to do at some point in time. I would imagine that what we'd get is a much lower value, maybe somewhere between 5 and 10% of these other DNA signatures would be associated with Dalcassian surnames, and that would really give a boost to this 29% that we see here. The third criterion that Dennis looked at in his study was among men with the clan-associated surnames, is there a significant preponderance of the specific DNA signature? So he collected men with the Dalcassian surname, and he found that the incidence of Irish type 3 signature was 57 out of 271, 21%. And he collected non-Dalcassian surnames, and when he totted that up, he got 10%. Now, Dennis didn't include statistical tests in his paper, but this was something that I did myself, and that difference between 21% here in the Dalcassian group and 10% of the non-Dalcassian group having the Irish type 3 signature, that is statistically significant, and is even more significant when you just look at those among the Dalcassian group that had the highest prevalence of surnames, and then we got 41% against 10%. And this on its own would make it highly likely that the Irish type 3 signature was in fact the DNA of the Dalgash. It's interesting up here, this 11% in the, among the butlers. They have got quite a high rate of Irish type 3, even though the butler name is obviously a normal name, Anglo-Norman, and it's not associated with the Dalgash. Or is it? Here is a lovely quote. Morgan O'Brien of Ballyphillip, County Limerick, married Eleanor Butler, daughter of Captain Edward Butler of Banshaw, descendant of Thomas Butler, the 10th Earl of Ormond. Higher social status. As was often the case, Morgan O'Brien took Butler, his wife's name as his surname, probably as part of his and his wife's succession to the lands of Banshaw, County Tipperary in 1690. So there's two reasons there. My wife has higher social status, I'm taking her name, and number two, she's got land and I'm going to get my hands on it. So those would be two very, very good reasons for changing the name, and it's a very good example of one of these surname or DNA switches. And it's nothing to do with illegitimacy or adoption or infidelity. It's quite an innocent switch. The fourth criterion that Dennis didn't actually use it in his study, but it happened very quickly afterwards, and that was the testing of Sir Conor O'Brien. Now, Sir Conor O'Brien is the 18th Baron Inchiquin, and he is a direct male line descendant of Brian Boru. Do we have any other direct male line descendants of Brian Boru here in the room? No? Okay. Well, he has a 30-generation pedigree. There's Brian Boru there, there's Sir Conor up there, and this is verified by the Chief Herald, etc., etc. And he tested positive for this SNP marker L226, which was subsequently found to be highly correlated with the Irish type 3 STR signature. And that is the SNP progression for Sir Conor. He is positive for L226, and then he is 1, 2, 3, 4, 5, 6, 7 branches below L226. So that's his particular genetic signature. And that lended credence that his extensive genealogy, going back to Brian Boru, was also consistent with the DNA evidence that had been collected to date. Probably the most important criteria, and it's only something that happened after the study, with the advent of SNP testing, most important criterion would be the branching structure in the clan-associated surnames family tree corresponds to the branching structure in the genetic family tree. And so that one can be superimposed upon the other. When we couldn't do this with just STRs, because the STR markers, there's a lot of noise there. There's things like convergence going on, a lot of false matching and chance matching, especially the further you go back. So it wasn't really possible to build very accurate genetic family trees using these STR markers. We had to wait for the arrival of the SNP marker testing. Things like Walk the Y and the Big Y, they really helped anchor the upper branches of the tree so we could focus more on the downstream branches with the STR markers. But like I say, the two markers work hand in hand. The STRs are better for the downstream branches and the SNPs better for the upstream branches. And various haplotrees arose as a result of this. Haplotree is just simply a diagram of the tree of mankind. I'll show you a few later on. We'll look at some of the pros and cons of each of them. So, after the study finished, SNP markers were introduced. We have had copious amounts of SNP data since 2009. And here are some of the SNP markers that various surnames have tested positive for. Now, it doesn't make much sense, or it doesn't mean much when you just look at them tagged on there. It makes a little bit much more sense when you look at how they are all connected to each other, and you can see that all of these markers go back to L226 and the branch below that. And most of them are associated with the branch below that, but you see a bifurcation here onto DC69 and on one branch and Z17669 on the other. And there's quite a few going down to this marker ZZ34. So let's put this into something more akin to a family tree, and this is what you get. This is a family tree based on these SNP markers with dates here on the left-hand side. And I did this by counting the actual SNPs, the number of SNPs in each block, each branching point, and assigned 70 years per SNP, because that's what Dennis Wright has currently estimated the number of years per SNP to be in his L226 project. And so what you see here now is a variety of surnames which are genetically related to each other. The big question is, can we superimpose this genetic tree on the clan-associated surnames family tree that we generated earlier? And here we go. This particular group of branches here include O'Brien, O'Hearn, Casey, and Kennedy. O'Brien, Hearn, Casey, Kennedy. So we're doing pretty well. The next ones along are Curry and McCormack. There we have Curry, and there we have Kerr-McCaughan. So the two of them, Kerr-McCaughan could be McCormack. And then further out we have Hogan and Casey, but there's no Hogan and Casey here. In fact, Casey is here, and Hogan is here. So that doesn't fit the picture, but everything here does. And that is pretty convincing evidence that the genetic family tree and the clan-associated family tree are complementary to each other. Now, as more data is collected, we'll probably see that this association becomes stronger and stronger. But this is a very good way of, and ultimately the most important criterion, I think, for showing that the genetics support what the ancient genealogies are saying. Now, there are some issues with the process, some challenges and possibilities, and I'll run run through a few of them. First thing is the surname dictionary, and anyone who's gone to a surname dictionary looking for their surname origin will find that there's 5 of them. 5 possible origins for your surname, and the big question is, which group are you? Like my Gleesons, not all surnames actually go back to a clan. So my Gleesons came from Muskerry, and they came from the same stock as the O'Donegans. But it's very, very difficult to find an ancient genealogy that actually has the Gleeson line within it. There are other dictionaries available. I don't know what your experience is, but I have never found anything in McLycett that I didn't find in Wolf. And Wolf is the one that I always go to as a first port of call. Again, it is also freely available on Library Ireland, and you can search for any surname under the category Irish names, and we'll come up with a lot of useful links, and particularly the reference in his surname dictionary to your particular surname. A lot of it is in Irish, and for those of us in the audience who are not Gaeilgeoirs or native Irish speakers, these 2 websites are actually very, very helpful. This is one from Trinity College Dublin. If you type the word in there, it could tell you how to pronounce it in Gweedore, Connemara and Dingle dialects. And also Forvo is very useful as well. You enter the search words there and it will give you a pronunciation as well. You have to take it with a little bit of salt, but especially for Irish Americans who want to do this kind of DNA project research, this is going to be indispensable because a lot of them won't have had Irish in school, etc. And speaking to a lot of them and hearing a lot of them, they do have trouble knowing how to pronounce the various names, like Drogheda, for example, etc. The clan histories. O'Hart is easily available online. Like I was saying, it's a little bit dodgy before 600 AD, so you do have to take it with a pinch of salt. And before the time of Christ, it does go into a lot of mythology. You can generate a tree of clan-associated surnames from O'Hart's account of the clans, but there are also many transcripts available online. Bartiaski's transcripts are really, really useful. He has 76 tables which are free to download. He basically has gone to all of the major genealogies, apart from Leabhar Mornan and Éileach, the great book of Irish genealogies. He's gone to all of the other ones, and he's compared them with the annals, and he has annotated them and put in dates to match the various branching points. Now he himself says that this is condensed. So again, if you're going to be comparing his tables with O'Hart's tables, it's very difficult sometimes to find the equivalence in both genealogies. So, but again, it's another useful source of information. And Bart gave a very useful talk at Genetic Genealogy Ireland in the RDS in October. And that's available online now. If anybody's a member of Family Tree Webinars, that's where it's being hosted, so you can find it there. This particular one is for the O'Malleys, which is one of my surname projects. Now the other very important book, and hopefully it's going to be digitized. I know Gerard has been striving to try and get this digitized for quite some time. It's the Leabhar Mornan and Éileach, the great book of Irish genealogies, written by MacFurbish in the 1650s or so, and edited by Nulago Morila from National University of Galway in 2003. And if you want access to some of the annals, there is a link to the list of Irish clans on Wikipedia, and a list of some of the ancient genealogies, and you can access them there. They're on websites like the UCC Cork website Celts, and a variety of other websites as well. Also, Catherine Sims has done a very, very useful assessment, critical assessment of these ancient annalistic materials, the annals, the genealogies, poems, prose tracts and sagas, and then legal and medical material, colophons and marginalia. So that's well worth a read as well. And like I say, Victorian scholars, when I was working on the O'Malleys, a Limerick clan of the O'Malleys emerged as a separate genetic group. Everybody thought, well, they must be related to the Mayo O'Malleys, but I was able to go back into some of the work done by some of these antiquarian scholars and show that, in fact, there's been an O'Malley sept in Limerick since at least the 1100s. And what we're seeing in Limerick now with this genetic signature is probably a very distinct clan to the Mayo O'Malleys. The family tree DNA is also very, very important in terms of finding projects that you can use to further your research. You can either Google FTDNA in your surname, that's the easiest way of doing it, but you can also look for specific clans as well by simply Googling FTDNA and the clan name, and also if you're looking at a particular geographic area, FTDNA and that particular county, and it will come up in a Google search, and that's just an easy way of shortcutting rather than going into the website itself and trying to figure out how do I find a particular project. For surname project administrators, they will be analysing, or they should analyse projects in a specific way. They ask a variety of different questions such as what's the dominant surname variant, because for example with the O'Briens we know that one group of O'Briens come from Brian Boru, but there's also O'Briens who are anglicised to O'Brien, and they're a completely different sept, but they carry the same O'Brien surname, but they'll have completely different origins. So looking at the surname variants is very important. Looking out for convergence and just chance matches, which are going to throw a fly in the ointment. Is there a surname or DNA switch evident? And if so, which came first? Was it the O'Briens, or Mr. Red, or Mr. Green? Where is the group from? And for this, we need all project participants to put in their MDKA locations, and not everybody does. And it's not very user-friendly on the FTDNA interface, so I'm pestering them to try and put an extra column in the results page that will actually show you the birth locations of the most distant known ancestor on their direct male line for each member of a project. Excuse me. Looking at the surnames of matches can give you an idea of where the person may have come from, but then extensive pedigrees are also very important. In my Gleeson project, the most extensive pedigree goes back to 1630, which I was very pleased with, and it is an indentured servant who went over to America in the early 1600s, and he has given, he's the progenitor of a whole line of Gleesons whose surname has morphed into Clesson, C-L-E-S-S-O-N. And he believes that most of the Clessons in America are related to him. I even found a Gleeson one time who said, I'm English, am I? And I said, we'll only, well, if you do your DNA test, I'll have a look at it. But and so when he did, and it came back, I said, no, I can confirm you match the North Tipperary Gleesons. He said, so I'm not English. I said, no, you're Irish. So he changed his password to colour me green. So DNA can be very, very, it can point you in the right direction, and it can certainly switch you onto a course of investigation you might not have heard otherwise. Another important part of an administrator's job is to estimate how old a particular genetic group is. And this can be extremely difficult because there's a huge wide range around the midpoint estimate. And you get that bell-shaped curve plus or minus 200 years to give you your 95% confidence intervals. And that doesn't really help when you want to know, is it my great-great-great-grandfather or my great-great-great-great-grandfather? 200 years on either side is not going to help. But for this we do need pedigrees, the tip tool. SNP dating is going to become much more important now because we've got many, many more SNPs than we had previously. And Dave Vance's SAP tool can be very useful from that point of view as well. Is it associated with an Irish clan? This is where you need to have big Y data, lots of SNP data, and the involvement of haplogroup project administrators in addition to surname project administrators. It's also important to understand the background of y-DNA transmission over the centuries, because this is in the UK, starting roughly about the time of Christ. The Romans come in, then the Saxons came in, the Vikings, and then the Normans. And you see that the population stayed very, very low for about 1,000 years, and then started taking off. And then we see these little blips, blips, blips. And what we have is World War I, and more especially the Spanish flu, wiped out about 3% of the population. Back in about 1640, we had the English Civil War, which wiped out about 5% of the population. And back in about 1348, we had the Black Death, and that wiped out somewhere between 20 and 33% of the population in the UK and Ireland, and 50% of the population in Europe. So with coronavirus going around at the moment, it probably pales into insignificance when you compare it to what happened in Europe in 1348. But of course in Ireland we have different things to consider. Cromwell's conquest in 1649 to 53 resulted in a 40% drop in the population. Now we can't be absolutely sure of the figures. It was about 1.5 million in 1640, and it was about 900,000 in 1660. So that equates to about a 40% drop. Compared to the Great Famine, where 1 million died, 1 million emigrated, there was only a 25% drop in the population when we're looking at the Great Famine. But the importance of this is that as this affects the evolution of a surname. Because what will happen is, as a surname evolves over time, yes, you're going to get DNA switches, allegiance to the Lord, social status, infidelity, adoption, and they're going to occur on various descendant lines of that particular surname. You're going to get surname switches as well. Maybe it changes to Flaherty there, it changes to Kilcoyne there. But watch this. You're going to get famine, you're going to get war, you're going to get pestilence, you're going to get natural disasters, wiping out entire descendant lines of that particular family tree. So some will die out, some will daughter out, because of this, if it's just the man has only daughters, then the y-DNA does not get passed on to the sons. It only goes from father to son, father to son, father to son. So today we've only got a very limited snapshot of the past. And we only see the survivors. And that's important to keep in mind. You see this more in haplogroup I, and less so in haplogroup R1b, because in Ireland you have groups like the Dalgash, like the Enail, Niall of the Nine Hostages, these powerful chiefs and warlords who had hundreds and hundreds and hundreds of descendants. And that ensured the survival of that DNA signature. But for some of the minor tribes, and especially for haplogroup I, which might have been Scandinavian, you do see some genetic groups in the present totally isolated on the tree of mankind, with the nearest genetic relative joined by a common ancestor 2,000 years ago. So that's another very interesting aspect of y-DNA transmission and evolution. We talked about some of the haplotrees, and these are basically diagrams of the tree of mankind. This is the big tree, which was started by Alex Williamson. The big advantage here, and the reason I love it, is because it has all the surnames. It does give some of the geographic locations, but only at the country level and not at the sub-regional level. And there's no dates. And also there's no private SNPs displayed on this diagram. You have to click on each individual to see how many private SNPs they have, SNPs that are just unique to that individual. And this is important information to know, because you'll be using it when you come to calculating the dates for the various branching points in this particular family tree. Another tree of mankind diagram is produced by Family Tree DNA called the Big Y block tree. Again, there's no surnames beyond the 30 private variants difference. So some surnames are here, but in the further branches of the tree you won't get the surnames. And that's a pity, because I need them if I want to do clan-related research. The big tree is the best one for surnames. None of the trees have adequate dates on them. Hopefully that will change. Private SNPs, They're present on the big tree, but the big Y block tree is better because it gives you a summary of the average number of private SNPs on each of these branches. And geographic origins are not refined enough. It would be nice if you could actually have the county level of these various branches of the tree of mankind. So to summarize, DNA allows us to identify the genetic signature of specific Irish clans, and the work that Dennis Wright has done with the Dá Gás has been revolutionary, really, and has given us a wonderful template that we can then attempt to apply to other Irish clans. This is going to help to confirm or refute the veracity of the ancient genealogies. And that is really interesting because hopefully we're going to see a revival of interest in clan-related research and a revival of interest in looking at these ancient genealogies and confirming whether or not they are accurate. It will also allow us to track the evolution and the migrations of the clan over time. So we do know that there have been internal migrations within Ireland of various clans, and the DNA is going to help confirm that this indeed has been the case. But it's all of this work is done by volunteer project administrators in America, in Australia, in Ireland, in the UK. They're all dissipated all over the world, and there isn't any centralized procedure or central organizing function that draws together on every individual project's research. And that's something that we definitely need to be thinking about. How do we go about organizing something like this? We also need better methods for estimating the branching points. And they are getting better, they are improving. And certainly talking to people like Ian MacDonald, Dave Vance, Rob Spencer, they've been working together and I'm part of an email group where they're bouncing very technical ideas off each other, but they're producing some really wonderful results, and hopefully that'll translate into something that's very user-friendly, that can be used by everyone over the course of the next few years. We also need comprehensive genealogies. So that would be extensive genealogies that go way back, preferably before surnames. Now I gave you the example of Sir Conor O'Brien, who's got that 30-generation pedigree back to Brian Boru. But Bart was talking about an even more extensive one that goes back to about 500, 400 AD. There are two people who are known to descend on separate branches from this particular ancestor. And if they were to do the Y-DNA test, and they matched each other, confirming that they are genetically related, then this would also help us anchor a particular branching point in the tree of mankind and help us date that particular branch. So we need more and more people with these extensive pedigrees to have the courage to take the test and to test up to the highest level, which would be the big Y test. Ancient DNA will also help to anchor that mutation rate, and the work that Lara Cassidy and Dan Bradley are doing in Trinity is really going to be revolutionary. Lara was at the RDS in October along with Bart and along with Ian. So you had somebody from ancient DNA, somebody from modern genetic genealogy, and somebody from the ancient genealogies, all coming together, and you could see, feel the buzz in the room, especially among the three of them. I was sitting beside Lara, and occasionally you'd hear her going, "Oh wow!" When she was listening to one of the other speakers. So I'm hoping that over the course of time there'll be more and more of this collaboration, and that we'll actually start seeing ancient DNA being plotted on the tree of mankind that we are plotting using our modern DNA. So that's something to look forward to. And like I say, these triangulated extensive pedigrees is going to be very important to have people with these extensive pedigrees to test as well. So that's a run-through of the current status of Irish clan research, and I think you can appreciate how DNA is really helping to revolutionize and hopefully revive a lot of interest in this particular type of research. So thanks very much for your attention. And
thank you very much.
pleasure.